This is the Atlantic project. The contributors to this project are myself, Carl Schmidt, and Harry Shuttleworth. The Atlantic project is a message builder and protocol designed as a smart contract layer between Chainlink's upcoming cross-chain interoperability protocol, or CCIP, and other decentralized applications. These smart contracts are homogeneous and could be deployed across a range of blockchains. For now, we're focusing on blockchains that support the EVM. Our smart contracts are also abstracted so that developers can integrate our message protocol into other smart contracts. Our tech stack uses Chainlink for the message transfer through CCIP, which we are mocking by using a Chainlink external adapter to transmit our messages from Ethereum to the Binance Smart Chain. We are also using Morales to independently connect to the Binance Smart Chain on our example dApp. So how does the Atlantic message transfer work? As said before, Atlantic works as a message layer between dApps and other smart contracts to Chainlink CCIP. Our message structure consists of a unique message ID used to track all messages that are created, a method to call on the receiving blockchain, the callback address on the blockchain where the user initiated the message from, an amount or fee of funds to be transferred or paid, the address of the smart contract on the destination chain, and lastly, a buffer of parameters that are passed with the method call. To send a transfer, a user creates a message on blockchain X and receives a message ID. The user then initiates the transfer using their message ID, which passes the message through CCIP to blockchain Y. And in our case, the message that passes through external adapter. One important note is that only the account who created the message can initiate the transfer when sending across the message through Chainlink CCIP. So now that we've seen how the Atlantic message transfer works, what are the benefits and goals of the project? Our protocol is general and standardized, which makes it easy to integrate with other dApps. Calling functions cross-chain and deploying contracts encompass a wide range of use cases. Our protocol is also repetitive. A user can send an identical message across multiple blockchains without having to rebuild their message, saving gas and time. Lastly, there is zero dev time. dApp developers don't need to build a cross-chain infrastructure. And I'm going to show you a demo of the project. So here's our example dApp, where we're going to send a message from Ethereum to Binance Smart Chain. We'll start by adding a method that will be called when we transmit this message to the Binance Smart Chain. We'll add in the callback address. This address is the address of our smart contract on Ethereum. We'll add an arbitrary amount, and then we'll also add the address of the receiving smart contract on the Binance Smart Chain. So next we can add some parameters that would be passed along with our method. The method that we're calling does not actually have any parameters, so we'll leave this blank. So now we're going to call the function. We should expect to have to sign two transactions, one to build the message and one to transfer the message through over to Binance. So here's the first. We're going to confirm. This builds the message, and here you can see that we've received a transaction hash. You can see here too that our message ID is 2. So now we'll assign the second, which will actually transmit the information from Ethereum to Binance. We click confirm. As said before, this transaction is happening through Chainlink external adapter, but the goal is to have CCIP. Okay. The transaction is now confirmed. We should be able to pull the message and look and compare between Ethereum and Binance. As you can see, we have our ID 2, execute function, the callback address, and the destination address.